Okay, ladies and gentlemen, for today's lesson, we're going to be going on from what we previously learned from combinations, specifically looking at combinations that have restrictions based on them. So for our learning goal, we will effectively be recognizing how some combinations have restrictions necessary to understand before solving. So for our first component, combinations including specific items. Effectively, if a selection must include specific items, then this reduces both the number of items that we have to select and the number of items we select from. So what this basically means, guys, if you have a group of things or people or whatever it might be, and you have to include select numbers of those, when you're looking at the overall n or number value, it gets reduced down. And that also occurs with the restrictions base too. So for our first example, John belongs to a team of 8 workers. How many ways can a team of 4 workers be selected if John must be on the team? Now normally, you'd look at the total number and your n value, or number value would be 8. It's not the case here, we have our restriction. John has to be included. So our n value is going to be 8, or our total, minus 1. With respect to this, because we need to create a team of 4 workers and John has to be included, that restriction there, instead of our R value being 4, it'll be 4 minus 1. Now we already know it's going to be a combination. So we substitute this into our values. NCR becomes 7C3. Plug that into your graphics calculator and it gives you an answer of 35. You'll notice I've not provided a word answer for this, but if you were to, the answer would be, if you had 8 workers and you needed to create a selection of 4, including John, there are 35 possible combinations for that selection of 4, including him. For our next one, the King and Queen of Hearts must be in the selection, so 3 more cards are to be selected from the remaining 50. So this is looking at just a regular deck of cards. We should all be aware that there are 52 cards in the deck, but because it already outlines the King and Queen of Hearts are being removed, that 52 reduces down to 50. And we also note that 3 more cards are being selected from the remaining 50. Before you go on, pause and see if you can figure this out for yourselves. All right, so now that we've given it a crack, for our n value, our total is 50. It would initially be 52 minus 2, but I'm just simplifying it down. 52 minus 2 is 50. Our R value in this case is 3, because we require a further 3 cards to complete our hands. So we plug these values in, 50C3, and using our graphics calculator, it gives the answer 19,600. For example 2, 4 students from a group of 8 students for the school volleyball are chosen from a group of 8 students for the volleyball team. 2 members don't get along and cannot be on the team. How many ways can the team be collected or created? So we've got a few key things of information. We know how many students are chosen from a group, 4. We know the collective amount of students, 8, and we are aware that 2 students cannot be placed onto this team. So pause the video and see if you can work this out. Okay, so our n value, or our first n value, is going to be 8 students. Our first R value will be 4. But we also need to include the 2 students that can't be introduced here. So for our second n value, it is going to be 8 take away 2, 6. And our second R value, 4 take away 2. For this one here, because they can't be included, we need to subtract a specific combination. So the formula for this one would start off with N1CR1 subtract N2CR2. We substitute our known values in. 8C4 minus 6C2. Please use the graphics calculator. It makes your lives easier. 70 minus 15, 55. Now, if you were to provide a worded answer, you would need to include the 55 possible combinations, and you would need to note the subtraction point here. So that's our first restriction. For our second one, will be based on combinations with multiple groups. Effectively, if we are required to make multiple selections from separate groups, then we multiply the number of ways of performing each task. Remember that? Multiply the number of ways. So for our next example along, from 7 women and 4 men, how many groups of 5 can be chosen? So have a pause, try this out. Okay. So first up, if we have no restriction, so without restriction, you have to add your components. In this case, our N value will be the total number of women and men. So 7 plus 4, 11. Not sure why I chose to write 1 there, but let's just change this here. And our R value, because we're needing a group of 5, it'll be 5. It's a combination. 11C5 gives us 462. If a restriction came in though, if it must contain 3 women and 2 men, so very specifics here, we have to use our multiplication principle. So we get our 2 sets of values. N1, which is 7 based on women. Our R1, which is 3 because we need 3 women. N2 for our men, there's 4 of them. R2 for 2 men. We multiply these 2 combinations together. So 7C3 times 4C2, which gives us 35 times 6, which equals 210. This middle section here is just to observe the numbers. If you plug that straight into a calculator, which is absolutely possible, and I expect you to, you'll just get our answer of 210. Going onwards. For part C, if we are containing at least 1 man in this group, we have to use all the selections of 5 people from the 11, then subtract the combinations containing all women. Think about why. So, N all, C R all. Subtract N women, C R women. So if we're looking at our all, there are 11 people in total and 5 in a group. There are 7 women in total and 5 in said group. Because we need at least 1 man, there's no possible way we'd have the restriction of 5. So we plug these values in, 11C5, subtract 7C5. It gives us our 2 values and our answer, 441. The last thing we want to look at though, containing at most 1 man. There must be either no men or 1 man present. Therefore, all women have to be added, plus the selection of 1 man and the selection for women. So first up, 7C5 plus 4C1, so that's the selection of all women, plus 1 man, multiplied by the selection of the remaining women, 7C4. Simplified out, 21 plus 4 times 35. Using BIDMAS, the multiplication goes first, which gives our answer at 161. The final restriction we want to include, and this one's a bit cheeky because it doesn't just look at combinations, it also looks at permutations and combinations combined. Some problems will require us to select and then arrange objects, permutations and combinations. So for example, 4. How many arrangements in the letters of the word duplicate can be made that have 2 vowels and 3 consonants? So obviously we've got our possible permutation, but we have the restriction of the combination present here. So if you look at the vowels and you count them out, we've got 4 total with our R value of 1. If you look at our consonants, 5 total with 3 restricted. So in letters in total, 5. 2 vowels, 3 consonants. We need to include a factorial for this because of the permutation being present. So we're going to have our N1s and R1 values, our N2 and R2 values, and we need to include our N factorial as well. So, plugging this in, let me just go a little bit further down so you can see. Our first combination, 4C2, which is looking at our vowels. Multiplied by our consonants, 5C3, multiplied by 5 factorial, the permutation of arrangements there. So 6 times 10 times 120, giving us an answer of 7,200. For the final of our examples based in this, a president, count with me everyone, a president, vice president, and secretary and treasurer, so 4, are chosen from a group of 7 women and 6 men. How many ways can this be done if exactly 2 women are chosen? So first up, we're going to divide things through, or I should say separate, no division here. When we're looking at our women, we have 7 in total, so N equals 7. When we're looking at the restrictions, we need at least 2, R is 2. For our men, we have a total of 6 here. But because we've already got a team of 4, 2 have been used, there's only 2 left over. So our R for men is going to be 2. And finally, because it's a partial permutation, because our N value, because of the number of possible spots is N, that means that N factorial must be 4 factorial. To finalize, we plug in our combinations for the women, 7C2. We multiply it by the combination for men, 6C2, and multiply it by the permutation of the number of people in the team, 4 factorial. So 21 times 15 times 24 to give us 7,560. Okay, ladies and gents, that's the end of our lesson here. I'll then set the questions for you guys to complete shortly. Thank you very much.